All right, Extrema sounds a lot more like difficult and crazy than it actually is. Okay, Extrema sounds like what word? Extreme. Okay. Sometimes we talk about extreme like extreme heat or extreme cold, right? Like it's the total opposite crazy ends of something. Okay, that's what we're going to be talking about with this is in a graph. And then behavior is just like how the line is behaving. All right, that's all it really is. So we're going to jump ahead to our learning goals. That'll make more sense after we go going. This is the first slide. We got to put some definitions on some things. All right, so the first thing, graphs of functions can have high and low points called extrema. You can paraphrase this. Okay, so you could say highest equals absolute max. You can paraphrase this into absolute max like that, as long as you know what it means. That's what I will do on the slides throughout here. Relative max like that. I would say this is really important, that superlative statement there, the highest point and lowest point. And then on the relative part, the most important thing is changes direction. It's a change of direction, but not necessarily the highest or lowest. A point could be both. It could be the absolute maximum and a relative maximum because it changes directions and it's also the highest point on the graph. I would highlight, underline, changes direction. I think that is really, really important. If you need a highlighter, there's some over here. Does anybody need a highlighter? Good. Anybody else? All right. About one more minute here. I know some people are still writing. Ten, 9, 8, 7, 6, 5, 4, 3, 2, yep, 1, 0. All right, next thing you're going to add is this little graph right here. Okay, sketch this out. Make sure just some important things. Make sure that this point up here, is higher than this one when you draw it. And make sure that this point down here is lower than this one. So just be careful with those things as you draw it. It doesn't have to be perfect or look exactly like mine. But just make sure that that's the case with those points. This is going to be your best reference in conjunction with the definitions, but your best reference as we work with relative max, relative min, absolute max, absolute min. All right, so starting left to right here, this first one that you probably drew is our furthest down, our lowest point. Okay, absolute minimum means that it is absolutely, positively the lowest in the whole graph. There's nothing that ever goes below that. And that's what that first point is. It is the absolute minimum. It is not a relative minimum because it doesn't change direction. Okay, if it were to change direction, then it would be a relative minimum. For example, if it looked like this, and we had that line there as well, then it would be an absolute and a relative. But because we don't have that, it's just an absolute minimum. Then we go up, okay, to this green point that I put here. This is a relative max. Why isn't this an absolute max? Why isn't the green point an absolute max? Why, Logan? It's not the highest point. Perfect, okay? The absolute maximum has to be the highest point on the graph. But we do have a change of direction there at the green point. It's going up and then it goes down. That's a change of direction, so that's a relative max. Then it goes down, crosses the x-axis again, and it goes to a relative minimum at C, the orange dot. Then the graph starts to go up. But right here, we have this little bendy turn right here, right? Why don't we have that labeled as something? Why isn't that a relative maximum or relative minimum? Or why, Aiden?
It's not like a high, or like it didn't stop and like go back down.
That second part is perfect, okay? It doesn't change direction. Does it flatten out? Yeah, it does flatten out, but it's still going up, right? It doesn't change direction and start to fall. It's still rising, even though it flattens out. So we don't label it anything. Then we get up here to this point. The red point is the highest point on the graph. Nothing is higher or above that. Okay, so that is an absolute maximum, but it's also a relative maximum because we change direction. It goes from rising to falling. Now this last point that we have drawn right here is not labeled anything, and that's on purpose. Make sure you don't have it labeled. Okay, it's not an absolute minimum because the blue dot is lower, right? And it's not a relative minimum because it doesn't change direction. Now, again, if I were to add on to this line and make it go like this, now this would be a relative minimum because it changes direction, right? Now it starts to rise, but it doesn't. Right here, it's not changing direction, so we don't label it anything. All right, give me a thumb gauge on that. Do those vocabulary terms make sense in the context of the graph? Awesome. All right, so we're going to identify this, the extrema of this function. All right, so sketch that quick. This is an easier one to sketch. This is an easier one to sketch. And then we want to try to find if we have a relative max or min or an absolute maximum or minimum. Now, Aiden had pointed out earlier that we want to be looking for those points in the graph where it changes direction, right? Well, in this case, there's only one of those, right? We're going to put a pink dot on it right here. Right there. Okay, now we have to ask ourselves, first of all, is that a maximum or a minimum? It's a minimum, right? Because it's low. It's a low point. So it's a minimum. Okay. And then is it an absolute minimum? Or is it a relative minimum? Is there anything on this graph that goes below that pink point? Nope. So that means it's what? Absolute. Absolute minimum. And then what is the point? So now we're going to give it a point. An ordered pair. It's at 0, and we're going to call it -5. Do we have any maximums on this graph? No. Why not, James?
There's no other points that it curves.
Yeah, what do those arrows do?
It goes on.
It keeps going. Okay, if one of those arrows, or if neither of those arrows went on and on and on, if they stopped, if we had a point at the end like this, then we would have a maximum. But they don't. Okay, they keep going. Logan?
Can it be both absolute and relative?
Yes, it should be actually. Great catch. This should be absolute and relative. Yep, relative minimum and absolute minimum. Great catch, Logan. That will depend a little bit on who you talk to. Like I know Mr. Vance downstairs, he just calls it absolute minimum. Miss Ullery's classes will label it as both. But yes, it can be both. All right, let's do the next one. Sketch this one for me. Guys, excellent job with the notes. I'm continually impressed with the detail and care you guys are putting into your notes. So then I want you to label your extrema and then identify the points. What do we have on this graph? What type of extrema do we have? What do we have? What's on this graph? Do we have relative, absolute, maximum, minimum? What do we have? Logan, what?
Relative.
Relative what?
Max and min.
Max and min. Where?
Relative max is like up to the left.
Okay, what's the coordinates?
-2 and then 8.
-2, 8. So you're telling me that that's a relative max?
Yes.
Okay. Where's you said there was also a relative minimum. Where's that at?
0 and 4.
0 and 4. Okay, what about our absolutes? Logan took care of our relative max and relative min. Where's my absolute maximum and absolute minimum? Gus?
The top arrow.
Yeah, but what's that arrow going to keep doing? So can we really put a point to it? No. So we're not going to put an absolute on here. There's not an absolute max or min because it keeps going and going and going and going and going. Okay, that's where we'd use that positive infinity, negative infinity for our range.
So the extremes
Yep.
are the curves, not the arrow.
The extrema are the change of direction or the highest point if it has one. Like again, if it keeps going up and up and up and up, you're never going to be able to determine the highest point.
So if that arrow was a dot, that would be an extreme?
Yes, if that arrow was a dot, it would be an extrema. Yes. So here, I'll draw it in. Let's do this. Let's say that this is some other kind of graph. And that it starts down here. What would we call that blue dot? That's an extrema. What kind? That would be an absolute minimum because it is the lowest point on the graph and it's not an arrow, right? It's a point. Okay. All right, now in behavior. This is very simple where we're at right now. It can be a little bit more complicated with how we do things, but we're going to really keep it simple. So we're going to focus on this one on the left here. You already have this drawn. This is the first graph we do. So just add this next to it or below, okay? I want you to just write end behavior. And then we're going to go left end, right end. Just like that. And literally all we're doing is describing what that end of the graph is doing. So on the left end, what's the end of the line doing? Is it rising or falling? Rising. Because this right here is going up, right? So it's rising. How about the right end? What's it doing? Rising. So we put rise. We're going to do the same thing for the other graph you drew, the squiggly one. Left end, right end. What's the left end doing on that one? We're going to use the words rise and fall. So the left end is fall, and the right end is rise. We're just describing what the end of that line is doing. Okay, so I want you to try this one. You're going to describe the end behavior on this one. It's a very simple line. Negative slope, linear function, left end, right end. Miguel, what's the left end doing?
Rising.
Rising. Good. It's going up, right? Riley, what's the right end doing? Falling. So we're going to put fall because it's going down. How about this one? We would put neither. Okay. This is a horizontal line. There is no end behavior because it just continues on the same, it would be y equals 2. Okay? Continues on that same plane. I think we've had enough of end of that. Okay, now we're going to apply this a little more. This is a graph of a drone flying, okay? We want to describe the end behavior, and then this is where we take it to the second level. We want to interpret it in the context of the situation. Okay? So on the left end for this graph, is it rising or falling? Because it goes right here, and then that would be a point, right? It's a stop. So what we would say here is actually it's undefined. And the reason that it needs to be undefined, can we have negative time? No. You can have negative altitude, that's fine, but we can't have negative time. And if this were to continue to fall, then we would end up with negative time, and that's just not a thing. 0 is 0, right? That's before they start flying the drone. So we would say undefined. The right end, we're going to describe this right here. What's it doing? It's rising. So we would expect that this drone is going to continue to get higher. It might go up and come back down a little, and then go up higher and then come back down a little, but we would expect that it goes higher. Does that make sense? Okay, pretty basic so far. Now we're going to do the same thing with this. So I want you to do this one. Mika and her friends get an Uber. They're going to a concert. Describe the end behavior and interpret it in the context of the situation. So left end, right end, and then what does it mean? Remember, they use their app to schedule the Uber, and the Uber drives to their location and picks them up, and that's when the graph starts, right? Okay. So when we're thinking about the left end, what's the end behavior of the left end of this? Russell, what's it got to be?
Is it going to be undefined?
Yeah. Okay, again, we're not going to have negative miles, right? Okay, it's not like you're going to get in the Uber and he's going to drive backwards and pay you for driving backwards. That's not how it works. Okay, so it's going to be undefined. How about the right end? Emma, what do we get on the right end? Rise or fall? Rise. Okay, so this was going to be a multiple choice question. It wasn't, but it should be D. Because x cannot be less than 0. What does that mean then? If we're going to interpret this to make it represent in the context of the situation, what does that mean for Mika and her friends? In terms of this situation, this context. What's that mean? Aiden?
The farther they go, the more money they do.
Does that make sense? Is that logical? The longer you're in the Uber, the further you ask them to drive, the more you have to pay. Makes sense. That's what that means. Okay? All right, we're going to do 3 checks here. So I want you to we're going to find the extrema of this graph. Okay, so find the extrema of the function. We're going to do 3 of them. So these are the first 2. You don't need to sketch all these. No, I'm not going to make you sketch all of them. But we want to find the extrema and then also describe the end behavior. So you need to describe the mins and the maxes, and then the left end and right end.
Get a buzz in the
Okay, we all have that one down? Okay, let's look at this one then. What's going to be our extrema and in behavior for this one? I'm going to zoom in for this one.
So do you want us to write it down the coordinates?
Yes, please put the coordinates down. Yep. So like one of the coordinates you should be writing down is 0, 0, because we have this point right here that's going to be something important. All right, let's look at them. So the first one, right, we have a real and an absolute minimum at -1. Should be -5 as well. -1, -5. We just have 1. Why don't we have any maximums listed here? Why, Aiden? Keeps going. Okay, left end rise, right end rise. Number 2. We have a relative minimum and a relative maximum. But again, no absolutes because it just keeps going. Any questions on those two? Okay, that third one, looking like the W. Okay, we do have some absolutes here. We have an absolute and relative. They would be both at -1, -1, and then also at 1, -1. And then we have a relative maximum at 0, 0. Why is this not an absolute? Why is that not an absolute maximum? Why is that, Brady?
Because it goes up more.
It goes up more. Yeah, these lines keep going up and up and up and up and up. So that's just a relative. And then left end rise, right end rise. Any further questions? All right, this is going to be your homework. It's a lot of the same.